Hey guys, welcome back to the channel, Malcolm V8. Today we're testing battery maintenance trickle chargers. Seems like a simple item and you'd think they all work the same, but surprisingly they don't. These are used on cars, motorcycles, lawn equipment, etc. that perhaps you don't drive very frequently or you store them over the winter. Either way, you want to come to find it with a charged battery. Now, some of these will leave you with a dead battery in certain circumstances because they do not work as you would expect. So let's test them all out and find out. Okay, now our testing criteria is fairly simple. When the charger is hooked up, it should begin charging the battery. Charge it all the way till it's full, and then stop charging and switch into a maintenance mode, which provides a trickle current because lead-acid batteries, even when disconnected from a vehicle, have an internal discharge that happens slowly over time. So we want to keep them on a maintenance mode. The other criteria is do not overcharge the battery. Also, the chargers should not overheat. We're going to check the temperatures of them. And of course, if there's a drain on the battery because there's a dome light left on, or maybe an alarm system or a keyless entry that's slowly draining the battery, it should switch back into charge mode if needed and bring the battery back up. They should also tolerate power outages. So let's get to it. So in order to get an insight into what each of these chargers are doing, I have a watt meter that I'll be inserting in line of the charger and the battery. I put the battery style, charger style quick disconnect ends on here so we can plug it right in. There's, as luck would have it, polarity is the same on all the battery chargers that seem to have a standard. So that worked out great for me fitting this in, no fuss. I can see the current, the voltage, and know exactly what's happening. We have the small lamp to simulate light current draws like electronics in your car or maybe even a dome light that gets left on. Then we have these two 100-watt spotlights to simulate large current draws, or perhaps I just want to pull the battery down to recharge it back up. And yes, they got very hot and started to burn my desk, and that's why I put a piece of wood under there. Before we jump into our first charger, let me explain what float current is. When a battery is fully charged, the charger should give it a very small amount of current called a float current to hold the battery at full charge. Typically on a car battery, that's around 13.2 volts, and you're only giving it about 10 to 15 milliamps. It's a very small current, and if the voltage were to start to rise, it would reduce the current, and if the voltage were to start to fall off, it would increase the current. The idea is that it's going to hold it at that steady, roughly 13.2 volts in a fully charged state. From all my reading on the internet, that's how it should work. If you know more about lead-acid batteries and have better or more accurate information, comment down below. Otherwise, this is the basis for comparing these chargers as well. First in our lineup is the Schumacher battery maintenance charger. Rated at 1.5 amps, I measured 1.6 amps, so it more than delivered on charging current. It also came in second to coolest on temperature, measuring only at 100 degrees Fahrenheit. It also tolerated power outages just fine. When power was resumed or power flickered, it would reset and start charging again. The only downside to this charger that you need to be aware of is once it's fully charged, it does not go into a maintenance mode to maintain the battery. It goes into something that it calls maintenance monitoring mode. And I had no idea what that was, so I Googled it, and the only reference I can find to it is on the Schumacher website. So it appears to be a self-coined term that they came up with. According to my meter, the charger is outputting nothing. It's just letting the battery sit there and essentially discharge. All lead-acid batteries have an internal discharge on them, which is why you keep a maintenance current on them. I added a small discharge with my orange light and let it start draining, simulating an alarm system or something else in your car. And the unit never ever switches out of maintenance monitoring mode. I let it drain for over a week and got all the way down into the low 11s, almost into 10 volts on my battery, and it still would not switch out of maintenance mode. So be aware if you're using this kind of charger, you likely want to disconnect your battery terminals to ensure nothing's going to drain the battery. And even if you have them disconnected, be aware if it's going to sit long term. All lead-acid batteries have a slow internal discharge, and this charger will never switch back into charge mode and top your battery up. It just lets it discharge. Next up on our list is this Black & Decker charger. Coming in at $30, it was $10 cheaper than the Schumacher. And it's only listed at 1.2 amps when I got it. I've noticed listings have revised to 1.5 amps. Either way, I measured 1.7 amps out of it, so you're more than getting the rated current. Coming in second hottest at 129 degrees Fahrenheit when charging. Seemed to do a great job with power outages. Tolerated them just fine, automatically started recharging. It did not have a float current when fully charged on a battery. Instead, I noticed that it had trip points where it turned on and off. It charged my batteries to 4.16 volts. It would then let them discharge and sit there with no maintenance current until they hit a trip point of 13.08 volts. As soon as the battery crossed that point, it kicked in the full current, 1.7 amps, and went to charge it back up. Next up on our list is this seemingly popular Foval unit on Amazon. and was recommended to me. It's rated at 2 amps and I measured it at 2.05 amps, putting out about 114 degrees Fahrenheit at full charge, running for an extended period of time. One thing that concerned me was the voltage on this battery charger when it fully charged the battery. It pushed it all the way essentially to 16 volts. I got 15.94, 15.96, always around that area on a fully charged battery. Pretty rough on a 12 volt lead acid battery, at which point it would turn off and there was no float current to maintain any sort of constant voltage. It would actually let the battery discharge all the way down to 12.4 volts. The other issue I have with the Foval is it did not tolerate power outages. After power flickered or went out, you have to literally go find the unit and push a button on it to make it start charging again. The other interesting aspect was when power went out, the charger actually started draining the battery. It put a 10 milliamp drain on the battery. It was the only charger out of the entire group that did that. Coming in at $23, it was on the lower end of the spectrum, and I feel like you kind of got what you paid for here. Another seemingly popular Amazon listing is the BYGD charger, and coming in at only $33 and rated for 5 amps, it seemed like a bargain, so I had to try it. And interestingly enough, rated at 5 amps, I only measured 2.7 amps. No matter what I did, I tried the battery at different voltages, I tried adding loads, discharges to it with my 100-watt spotlights, whatever I did, it only gave me 2.7 amps. It charged at a temperature of around 86 degrees, and I found the trip points for its charging was 13.65 on the low end and 14.24 on the high end. So it would charge up to 14.24 volts, and this one, when it turned off, although it did not provide a constant float current, it would pulse 20 milliamps in a frequency, sort of pulse, 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 just like that. And it would try and maintain a voltage somewhere between the 13.65 and 14.24. If it went below the 13.65, such as if I turned on my lamps to create a load on the battery, it would suddenly spike at 5 amps to do a short little top up to get back into that charged range. And that's the only time you ever see 5 amps out of it. If you drain the battery or you get a slightly discharged battery and you hook it up, you'll only see 2.7. So I find that 5 amp rating a little bit misleading because that's only what you get when it spikes a top up that's dropped below a trip point. And it was also the only charger in the group that had a fan, and it was noisy too. Next on the list is the Motopower battery maintainer, rated at 4 amps, measuring in at 4.02 amps. Just like all the other chargers on this test, it did 6 and 12 volts, only came in at $28. While charging at full power, I measured it at 145 degrees Fahrenheit, and that's in a 74 degree air-conditioned room, so I would definitely be cautious of using this in a hot garage or something in the summer. It's very likely to overheat and burn up. It charged up to a full charge of 14.24 volts, exactly the same as the BYGD. Only it let the battery drain down all the way to 12.79 before turning back on to start charging. There was no float mode, so to speak of, it just toggled between those 2 points. It also sustained power outages and came back on automatically. Okay, last but not least, we have the battery Tender brand. I picked the 4.5 amp model, and this one came in at $100, more than double the next most expensive on this list. Testing it, it gave me 4.65 amps charging, so every bit that I paid for. Charging at 127 degrees Fahrenheit was about middle of the range, and it charged all the way up and actually switched into float mode. It held float mode at 13.16 volts. And you could see it maintaining a specific current to hold that voltage once the battery was charged. It slowly trickled down to eventually it went to 0 amps, and then every few seconds it would pulse about 10, 15 milliamps to keep the battery at 13.16. This is pretty much classic textbook of a good healthy battery. And to experiment with that, I would turn on my amber light simulating a dome light, creating a load, and you would see it ramp up the current in milliamps however much it needed to keep maintaining that float current. And if I turned on a heavy load like my 100-watt spot lamps, it would switch back into charge mode. I'd see it ramp right up to 4.5 amps and try and maintain what was being lost from the battery. Once the load went away and the battery got charged again, it went right to that 13.16 float and held it there. Textbook classic of how I read a battery should be charged and maintained. It did it exact. It also tolerated power failures as you would expect and came back on and charged every time. Here we can see all the chargers side by side. Perhaps cord length and the reach of the charger is important to you. So the longest one out here on the left hand side is the battery tender model, coming in at 13 foot 8 inches, closely followed by the Schumacher at 13 foot 5 inches. The Black & Decker was 12 foot 9 inches, the Foval was 12 foot exactly, the Motopower was 11 foot 10 inches, and the shortest by comparison there is the BYGD at 8 foot 3 inches. Alright guys, there you have it. That's our line of battery chargers and the results of testing from them. I hope you learned something. I know I sure learned something. And I know what's my favorite now going forward and what I'll be buying in the future for battery chargers. Now something interesting, a nifty little trick I came up with along the way. For the Schumacher chargers that don't want to restart charging when the battery is draining, I went ahead and grabbed one of these nifty little smart plugs. I'm sure you guys have seen these. You plug them in an outlet. They're Wi-Fi operated. You connect it with your smartphone and you can program them to do whatever. So I went in there and I programmed in the middle of the night, like say 1 a.m. to turn off. And at about 1:05, turn back on. And this causes the charger to reset because it gets power cycled and it starts charging. So if the battery had been draining since the previous time it was charged up, your maintainer resets and starts charging. So there's a neat workaround if you're already invested in some of those and you have some smart plugs laying around.